Okay, Assalamualaikum and good morning. Okay, we continue our topics. Okay, for the CSC429. Okay, so saya harap anda semua boleh menguasai conversion binary, octal dan juga hexadecimal. Tak kisahlah sama ada from the decimal to binary, binary to the decimal, or from the decimal to octal, octal to decimals, decimal to hexadecimal, and hexadecimal to the other bases. Okay, so antara binary, octal dan hexadecimal ini penting kerana setiap komponen komputer akan menggunakan representing your data into this kind of numbering system. Jadi, okay, anda conversion dalam number system sangat penting lah, okay, supaya kamu boleh buat ada lagi daripada exercise, ada lagi things yang happens di dalam komponen komputer. Selain daripada conversion, we also can do some addition and also the subtraction. Okay, so how we do the addition and subtraction? Okay, in the binary numbers. Okay, contohnya in the base 2. For example here, okay, we have example 1 here. Okay, let's say they given you a number, the binary number. Okay, so this is a base 2. Both are base 2. Okay, so the example 1, okay, they have at the example. Okay, so if they given you a binary numbers, okay, and you have add these two binary numbers. So what the computer do when they're adding these two binary numbers, they start the numbers, okay, from right to the left. Don't ever try to do the addition start from the left. Anything is start from the right. This is a normal like macam you buat proses tambah dalam decimal juga. Tu cuma dia dalam binary. Okay, 0 campur 1 dia akan dapat 1. 0 campur 1 dia dapat 1. 1 campur 1 dia adalah 2. Nilai dia 2 kan? Tapi bila nilai 2, dia tak boleh letak 2 kat sini. Sebab 2 tak ada dalam binary punya numbers. So, 2 adalah sebenarnya dia adalah 1, 0. Jadi, 0 letak sini dan 1 bawa naik ke atas. So, awak tambah macam biasalah. 1 plus 1 plus 1 is 3. When you have 3, you have 1, 1 in the binary. So, you have 1 here and carry will be have 1 here. So 1 plus 1 is 1, 0. So 0 plus 1. 1 plus 1 is 1, 0. So 0 plus 1. And 1 plus 1 is 1, 0. So 0 plus. So the 1 will be carried out and then put in at the top at the left bits. And then 1 plus 1. 1 plus 1 is 3. And 3 is actually 1, 1 in the binary. So it should be 1 and have a carry here 1. So this is how you add, okay, the binary number in, how you add the numbers in binary. Okay. Okay. Okay, so dia tak binary number lah. Okay. Alright, for the example 2 shows how your binaries can be subtracted. Okay. So bila kita subtract macam biasalah. Ini subtraction, normal subtraction. So 1 plus 1 minus 1 is 0. Okay. Fine. Okay, it's much easier. Okay, 1. How about 0 minus 1? So the 0 minus 1 here. Okay, what shall you do? You akan pinjam. Okay, pinjam. Okay, pinjam sebelah. So sebelah ni bernilai 2. Okay, so bila you potong dia akan menjadi 1. Bukannya negatif, tak. Dia akan jadi 1 dan 1 sini dipinjamkan ke sini. So 1 tolak 1. 1 tolak. Dia pinjam. Okay. Dia pinjam 1 di sini. 1 plus 1, it should be 1 minus 1. Okay, dia punya satu. Satu sebenarnya dia adalah 2 kat sini. Okay, right. So, dia pinjam kat sini. Nilai we talk about the nilai. Okay. Okay, nilai dia adalah 2. So, 2 tolak 1 adalah 1. That's why dia jadi 1. Okay. Alright. So, this is 2. Okay. So, okay, dia tinggal 1. So, 1 turun dah. Okay, 1 ni memberi nilai 2. Okay, nilai 2. Sebab in the base tu kan. So, nilai dia adalah 2. So, jadi, bila you tolak, bila berlaku proses peminjaman, walaupun dia pinjam 1, okay, tapi dia membawa nilai sebanyak 2. So, bila dia pinjam 2 tolak 1 ialah 1. Okay, so yang ini, walaupun dia tinggal 1, tapi dia tinggal 1 lah. Nilai dia tadi sebenarnya asalnya 2. Okay, right, 2. Okay, tetapi dia dipinjamkan ke sini, dia tinggal jadi 1. So, that's why di sini 1 sini. Okay. And then, 1 turun ke bawah. And then, sini, kenapa di sini dia jadi kosong lah. Sebab 1 tadi dia dah pinjam sini. Dia tak ada nilai. Okay. Dia adalah kosong. So, bila dipinjam sebelah, which is 2. Dan 2 ni dipinjam sebelah. Okay, dia tinggal 1. That's why dia tinggal 1. Okay, so di sini jadi kosong. Okay, and then, dia akan jadi 0, 1, 1 kosong dalam binary. Okay. Alright. So, saya ulang Okay, bila kita tolak. Okay, saya padam sekejap. Okay. Okay. So, bila ada kes peminjaman di sini. Okay, bila kita tolak. Okay, kita akan tolak macam biasalah. Okay, 1 minus. Okay, kalau dia sama, nilai dia akan kosong. Okay, 1 tolak 1 kosong. So, I hope you will understand this kan. And then, tetapi apabila dia nak tolak 0 tolak 1, tak boleh kan. Okay, so dekat dalam base number, mana ada negative number. Jadi, macam mana dia nak buat? Dia kena pinjam sebelah. Sebelah pun kosong. Okay, jadi dia tak boleh pinjam sesukati. Dia kena pinjam lagi orang sebelah. So, bila orang sebelah ni, dia tinggal kosong. Okay, dia tinggal okay, dia tinggal kosong. Okay, dia tinggal kosong. Saya punya ni dia. Okay, dia tinggal kosong. Okay, dia tinggal kosong. Jadi, 1 yang tadi tu dipinjam kat sini. So, 1 yang nilai yang dia bawa tadi sebenarnya nilai dia adalah 2. So, bila dia 2. Okay, bila dia 2. Okay, dia pinjamkan dia 2. Okay, dia pinjamkan sebelah. So, dia pinjamkan sebelah, dia jadi 1. Okay, sini dia jadi 1. Okay, so bila sini nilai dia akan jadi 2. So, bila 2, ni silap ni. Okay, dia jadi 2. So, bila dia 2, so 2 tolak 1, dia akan jadi 1. So, tadi dia pinjam sebelah, dia tinggal 1. So, 1 ni turunkan lah. So, ini akan jadi kosong. So, jawapan dia ialah 0, 1, 1, 0. Base 2. So, this is how you do sum subtraction. So, I hope you can, nanti letak you akan buat latihan, okay, dalam the next slides. Okay. Alright. So, macam mana octal dan hexadecimal? Okay. So, bila octal dan hexadecimal, okay, you kena tengok, okay, untuk octal pula, okay, you tengok, okay, so the rule of thumb dalam octal number ialah dia tak ada nombor 8. The maximum values dia mesti 0 hingga 7. Kalau dia tambah, of course nilai dia akan bertambah. So, bila benda tambah, nilai tu awak kena tukar dia dalam octal. Contoh, okay, you have a 333. Okay, this is the base 8. This is the base 8 and this is base 8. This is base 8. Okay, 3 plus 6 is 7. 3 plus 6 is 9. So 9, the value dia is more than 8, right? So 9 di dalam base 8 dia adalah 1 sah 1. Okay, so 1 kat sini, 1 naik atas. Okay, kalau tak pasti, awak buat. Ambil 9, awak bahagikan dengan 8. Okay, you dapat 1. Okay, dan remainder dia pun sah 1. Ini 1 bahagi 8, you dapat kosong. So, remainder je sah 1. So, dia akan 1, 1. Okay, alright. So, 1. Jadi, 1 di sini. 1 lagi, another one will be carried out. Okay, so 1 plus 3 is 4. 4 plus 7 is 11. Betul? Nilai kita talk about nilai. So bila 11, okay, bila dia 11, so 11 di dalam base 8 adalah 13 base 8. Okay, 13 base 8. Okay, bila dia 13 base 8, okay, 13 base 8. So 13 base 8, so 3 ni ke sini, 1 naik atas. So campurlah 1 campur 3, 4, 4 campur 4, 8. So bila 8 pun tak ada dalam base 8. Okay, base 8 adalah 1 kosong base 8. Okay, 1 kosong base 8. So kosong kat sini, 1 naik atas. So jawapan you 1031 base 8. So this is how you add in the octal number. So basically nilai dia dalam ni 0 hingga 7 je. Lepas daripada tu 8, 9, 10 onward dia dah reset dah jadi kosong, tapi dia ada extra digit sebelah kiri. Okay, kalau awak tak percaya awak kira 8, 9, 10 sama. 10, 1, 0, 1, 2, 1, 1, 1, 2, 1, 3, 1, 4. It's the same. Okay, right, tak payah kalkulator pun boleh. Tapi kamu kena tahu kalau start dengan base dia sendiri, dia akan start dengan 1 kosong. 9 dia jadi 1 1. 10 dia jadi 1 2. Dalam base 8. Ini semua base 8 ini value dalam values dia. Okay. Kalau 11 dia jadi 1 3. Percaya tak? Sama kan? So itu cara dia lah. Okay. Alright. Cara mudah lah. Okay. So dia akan reset. Sampai dia jadi 1 7. For example. And then bila dia tak ada 1 8. 1 8 dia tak ada. Jadi dia kosong balik. Tapi dia akan cari put an extra 1 in the left. So dia jadi 2 0. Okay. For example. Like 16. Okay, nombor 16. Okay. Alright, for example lah. Okay. Jadi, untuk subtraction dalam octal, okay, subtraction dalam octal, kecap ini subtraction biasa, okay. Dan bila kita tolak, okay, for example here, 723 base 8. Okay. Okay, so you minus with a 536 base 8. Okay, so macam ni kita tolak. 3 minus 6. Okay, 3 minus 6 is basically yes. Okay, 3 minus 6 is tak boleh tolak kan? It should be negative kan? So is there any negative values in the base 8? No, tak ada. So what shall we do? We have to borrow. Okay, tinggal 1. Betul? Okay, tapi nilai yang dibawa sebelah bukan 1. Tapi adalah 8 sebab you are in the base 8. So 8. So jadi 8 you campurkan dengan 3. Dia jadi 11 kan? So 11 tolak dengan 6 baru dia boleh tolak dengan 6 kan? So 11 tolak 6 dia jadi 5. Tu cara dia. Okay, so dia pinjam 1 maksudnya dia carry the numbers of 8. The values, we talk about the values is 8. So 8 plus 3. Okay, and then you minus with the 6. So you dapat 5. Okay, same goes to here. So 1 minus 3. Okay, you cannot 1 minus 3 because you cannot have a negative value in the base 8. So you borrow here 1, which is 6. Basically dia tinggal 6. Tapi sebenarnya dia carry about 8. The value of 8. Because you are in the base 8, right? So 8 plus 1 is 9. And 9 plus minus 3 with, you got a 6. So 6 minus 5, basically you boleh do the sum normal subtraction. So 6 minus 5 is 1. So you have a 165 base 8. So is that clear how you calculate the subtraction? for the base 8 or octal numbering system. I hope you can understand. Okay, if you don't have you don't still not understand, so we will explain to you more. Okay, and do some exercise. Okay, all right. Okay, now we go to the hexadecimal numbers. Okay, so in the hexadecimal numbers, since hexadecimal is using a base 16, so the value of the base hexadecimal is 0 to 15. You have to remember that. And the decimals, the values for 10 to 15 represent by letter from A to F. This one you have to remember based on the learning in the previous class. Okay, so in the hexadecimal numbers, okay, when you add on the hexadecimal numbers, this is the hexadecimal numbers. Okay, alright. So how you add? Okay. So bila add kita tak ada masalah. Cuma when you do have more than 15, then you have to reset back. Okay, to 0. Okay. So reset balik. Okay, tengok nilai yang sudah ada. So for example here, you have 3 plus 8. Okay, 3 plus 8 is 11, right? You tak boleh letak 11 kat sini. Sebab 11 is represented by B in the hexadecimal ni. Okay, actually represented by B. Okay, you have to remember that 10 is A, B, C, D, E, F. You count from with your finger. Start right 10 represented by A until 15 is represented by F. So 3 plus 8 is 11. So 11 is represented by B. Okay, so now 2 plus 2 is 4. Still remain the same. And A is a 10. Okay, A is 10. Okay, and C is really 12. So A plus C, you got 22. So 22. Okay, so A plus C is 22. So 22 is basically you have a 22 minus 16. Okay, you have carry 6 carry with 1. Okay, so you have 6 and 1 at the birth. Okay, 1 plus 1 is 7. 1 plus 1 is 2. 2 plus 7 is 9. Okay, so maybe you tak faham dekat sini. So 16. Okay, so you have a 22 here. Okay, 22 you divide by 16. Okay, you have 1 here. Okay, so 22. 22 minus 16 is 6. Okay, alright. So 0, 1. So you have a 1, 6 base 16. Okay, 1, 6 base 16. So 6 here and followed by 1 here. Okay, followed by 1 here. 1 plus 1 is 2. 2 plus 7 is 9. So that's how you calculate the ni. Okay, because kenapa 22 ni lebih daripada base 16. So nilai dia akan bertambah. Okay, so 15. Kalau you start daripada 16, nilai 16 dia jadi 10 dah. Kalau dia jadi okay, bukan tolak di sini, bahagi. Okay, bahagi disilap. Okay, 16 ataupun guna cara tolak pun boleh. So 22 tolak 16. So you have a 6 with a carry of 1 because it's more than 16. So you have 1. So 1, 6 lah. Ni cara teknik baru, cara baru untuk hafal. Kalau you have a 30. Okay, minus 16. Actually is 14. With the carry 1 kan. So 14 ni is represented by E. So 1E. If you not believe me, try to convert using calculator. Okay? Alright. Okay, so 14. 14 ni ada dalam nilai B16 which is E. So E carry with 1. So ada extra 1 on the left one. So you have 1E. So E 1E. Okay, so dalam kes ini dia adalah 22. So 22 you minus with the 16. Dia guna cara tolak. Ada cara bagi. Kalau ini cara yang kita conversion biasa. Ini digunakan tolak untuk mudahkanlah dapat. Okay, 22 tolak 16 which is 6. Okay, perbezaan dia. 6 with a carry of 1. So 1, 6. 6, 1. Okay, 1 plus 1 is 2, 2 plus 7 is 9. So this is how you represent your numbers, okay, addition in the hexadecimal. Okay, next. Okay, hexadecimal on how the hexadecimal subtraction the hexadecimal. Okay, in the subtraction of hexadecimal, okay, the values also still the same in the 15. The value maximum is 15. So kalau dia kasi awak jangan pelik pula, A tolak 2. Okay, A ni represent by 10. So 10 tolak 2 kita akan dapatlah 8. Okay, how about 0? So di 0 ni kita pinjam. Ni pun pinjam 0. Okay, dan sebelah ni soalan dia adalah F. Okay, soalan dia sebenarnya F. So bila dia F, kita pinjam 1. Okay, 15. Okay, pinjam 1. Okay, dia jadi E, 14. Okay, so 1 ni dibawa ke sini. Okay, 1 ni dibawa ke sini, which is 16. Dia bawa kiri 16 kan. So, bila dia dah pinjam sebelah, dia tinggal jadi 15. Okay, alright. So, bila dekat sini, so 15, okay, alright. So dia jadi, bukan 15, dia 16 dekat sini. Okay, so 16 tolak B, B adalah 11. Okay, so bila 16 tolak 11, dia ada 5. 11 ni represent by B, and bila dia dah pinjam 1, 1 tu membawa maksud nilai 16 sebab dia dalam hexadecimal, base 16. So 16 you minus with the 11, which is represent by B tadi kan. So 16 tolak 11 dia jadi 5. So you akan dapat jawapan 5. So how about this? Okay, tadi dia pinjam sini. Okay, dia ada 16 value. Value dia ialah 16. Dah pinjam sebelah menjadi 15. So 15 kita tulislah 15. Tapi kita tak boleh tulis 15. Kita tulis 15 sebagai F. Okay, sebagai F. Alright. So yang ini turun je lah. E and 1. Kalau ada nilai lagi, you kena tolak macam biasa. Tapi ini jawapan dia dalam base 16. Alright. So this is how you do the addition and the subtraction in the hexadecimal. Okay, so I need you to do this exercise later on. Okay, alright. As part of your exercise, okay, this is a part of your exercise, okay, in order for you to make and understand, okay. So you can put this exercise in the stream so that we can have some discussion. It is all in the WhatsApp group so that if you have any issues, okay, we can solve together, okay. Alright, same goes to here for the hexadecimal, okay. So now we go to the next one, which is the signed and unsigned numbers. Okay, so previously, okay, you only learned, okay, the numbers, okay, either the binary or octal or hexadecimals, okay, and the decimals number. Of course, obviously you tahu lah, okay. So basically kalau kita nak tahu, okay, bila numbers tu, okay, they have a numbers that is used as a signed and unsigned numbers. In the computer, okay, CPU will perform the arithmetic and compare the operations for both by type equally well. Okay, macam mana dia nak bezakan sama ada nombor tu ialah nombor biasa ataupun unsigned numbers. Okay, so the numbers with only a positive values, okay, they have 8-bit storage location. Okay, maknanya 8-bit storage location that store the unsigned integers, okay, between the 0 to 255. Okay, sebab ada certain register atau dia akan menggunakan 8-bit. Ada certain register dia menggunakan 16 bit. So cara dia locate tu, cara dia gunakan, dia punya values akan berbeza. Okay, so kalau unsigned numbers, okay, dia tak melibatkan sign sama ada dia ni data positif ke negatif ke, tak ada. Okay, alright. So macam mana CPU nak tahu, okay, mana nombor tu is a signed or unsigned numbers. Okay, so unsigned numbers can be converted directly to the binary and they processed without any special care. Okay, so itu perbezaan dia. Lagi satu nombor yang unsigned numbers, okay, dia punya storage location dia antara untuk 8-bit 0 hingga 255, untuk 16-bit antara 0 hingga 65535. Okay, so dia tak perlukan sign. Okay, tak perlu. Contoh, okay, when you do some declaration, contoh you declare variables untuk simpan address. Address kan kita ada nombor juga kan. Nombor 35, nombor 1, stroke 2. Okay, so macam mana komputer nak identify whether this is a numbers or is it a numbers or is it like macam character or letter. Okay, the treat as that numbers is as a character and letter sebab semua number akan jadi binary. So macam mana dia nak tahu that one is not a numbering for arithmetic. Itu persoalan dia. So that's why they use a unsigned numbers. Okay, unsigned number ni contoh bila kita buat declaration, okay, bila kita isi dalam address, text, okay. So text pun boleh jadi nombor. Okay, jadi cara dia convert tu dia akan jadi unsigned numbers. Ini dalam machine we talk about dalam machine. Okay, that's why kalau kamu declare you punya dalam coding, okay, dalam coding you ada long integers, okay, double integers, because they declare the variable within the size of the variable. Okay, sebab yang itu dia akan locate benda tu, setiap variable yang you declare tu, dia akan allocate benda tu di dalam you punya memory. So, kalau kamu tak buat the real declarations of your variables, so how your computer knows whether that is belong to the text or that is belong to the numbers? Okay, so sebab dia semua tukar kepada binary. Jadi dia akan, bila you declare the right one, okay, long integer ke, float ke, so dia akan tahu where is the signed numbers and where is the unsigned numbers. Okay, unsigned numbers ni normally nombor-nombor yang kita gunakan untuk letak location, your date of birth, okay, years, so on, okay, yang tak perlu ditambah. That's why dia boleh convert directly kepada binary. Okay, untuk arithmetic, okay, contohnya you buat subtraction, you buat pecahan, you buat multiplications, okay, you buat division, so on. They have a values or numbers. They have numbers that have a negative numbers. So they have a several forms and how we present into a binary. Okay, contohnya dia ada integer kan. So dia ada negative apa something kan. So macam mana disimpan, macam mana dia perform, how it is being processed. So dia ada 3 cara. Sama ada cara pertama adalah menggunakan sign and magnitude representation. Okay, which is yang normally is negative values lah. Okay, negative numbers. Positif tak apa sebab dia almost the same. Tapi untuk negative numbers, okay, that's why we split the numbers into signed and unsigned numbers, because when you do arithmetic operation, dia akan define whether that is a number is a signed numbers or unsigned numbers. Okay, so for the negative numbers, you can process. It depends on the process that takes place. It depends, okay, whether it's use a sign and magnitude representation, first complement representation, or the two's complement representation. Okay, so in the sign and magnitude, okay, in the daily usage, sign integers are represented by the plus or minus sign and the value. So kalau kamu buat computer operation, ada positive and negative values. So how your computer differentiates whether that is a numbers is a positive or whether is a negative. So normally the numbers are positive is represented by 0. Okay, alright, and the number negative will represent by minus. If you have put minus negative 3, for example, you type minus 3. So bila computer treat that is a integer which is with a negative 3, so dia represent F negative. Dia akan nilai lain. Contoh, saya minta awak tekan calculator. Okay, you tekan 3, okay, tukar kepada binary. And then kemudian you tekan negative 3 dalam binary. So sama tak jawab binary dalam 3 dan juga negative 3? Tak sama kan? Okay, kenapa? Sebab cara komputer simpan nilai positif dan negatif adalah berbeza. Okay, so that's why you kena tahu. Okay, kita tengok cara sign and magnitude, macam mana the sign magnitude representing while during the process. Okay, so untuk memudahkan cara dia, in the sign magnitude, the leftmost bit in the binary is considered as a sign bit. Okay, so katakanlah dia has 8-bit representation. So the leftmost bit, okay, the bit ke-8 akan represent the sign bit. Okay, and then the another 7 bit tu represent by the magnitude. So magnitude tu kita consider as a value lah. Okay. Alright. Okay, contoh Okay, kita ada 8 bit Contoh 1, 2, 3, 4, 5, 6, 7, 8. Okay, you have a 8 bit of binary. So, this bit, the leftmost bit yang saya kata tadi tu, the leftmost bit here represent by sign bit. Okay, and how about this one? This one is represented by the magnitude. Okay, magnitude. Okay, alright. So this is a sample. Okay, kita nak tengok beza antara positive 37 and the positive negative 37. Okay, so bila kita kata positive 37 and negative 37, macam mana you nak tahu adalah, okay, first you convert, okay, the 37 ni into a binary. Okay, you akan dapat 1001101. Okay, so since they are positive, so the leftmost bit you put with the 0 sebab to represent the, nak represent the positive. Sama juga dekat sini, 37. Okay, ni nilai 37. And then, since they are negative, so they are represented by 1. Okay, so this is how the sign magnitude. Okay. Alright. Kenapa in the sign numbers, okay, basically untuk pengetahuan anda, bila you pakai sign numbers, okay, alright, bila sign numbers, okay, so dia punya range, okay, the range for 8 bit, kita ada 8 bit register location. For sign numbers, 8 bit location, okay, dia akan kurang sebab dia dah gunakan sebahagiannya untuk negatif dan juga positif. So range dia berbeza lah. Okay, so okay, start with, sebab ada kosong, we start with the negative. One to 8. To the positive 1 to 7. See? 16 bit. Positive 3 to 7, 6, 7. Okay, dia kena kurang satu sebab dia akan buang kosong. Kejap. Okay. Okay. Fine. Okay. So 8 bit. Okay. Saya padam sikit sebab tak nampak Okay. Okay. Ni 6 Okay. So macam mana Miss tahu dia 8 bit? Okay. Bila kita 8 bit, okay, 1, 1, 1, 1, 1, 1, 1, 2, 3, 4, 5, 6, 7, 8. For example. Okay. So 8 Kalau sign numbers So this one. Okay. This one is represented by negative kan tadi? Okay. Kita kata point 1 is negative, betul? So this one, you tambahkan, dia jadi berapa? 1, 2, 4, 8, 16, 32, 64. Which is 128 kan? 1, 2, tak cukup. 1, 2, 3, 4, 5, 6, 7, 8. Okay. This one, 1 campur 2, 3. 3 campur 4, 7. 7 campur 8, 15. 15. Ini 1, 2, 4, 8, 16, 32, 64. So awak totalkan semua ni. 3 campur 4, 1, 2, 4, 8. Okey, 3 campur 4, 3 campur 4 dah 7. 7 campur 8, 15. 15 campur 16, 31. 31 campur 32, 63. So 63 campur 64, 128. Okay. So kalau kamu kira dia jadi negatif 128 dan bila sampai range dia sampai positif 127. Kenapa dia tak 128 juga? Sebab kita ingat kita ada kosong. Okay. Untuk ini adalah untuk 8 bit dalam sign numbers. Okay. 8 bit dalam sign numbers. Okay. Kalau 16 bit, 16 bit macam itulah kita kira. 16 bit ada 16 bit. Bit yang ke-16 should be his sign numbers. Okay. Another 15 bits tu will represent by the magnitude. So that's why the value dia jadi negatif 32,768 hinggalah kepada positif 32,767. Okay, so this is very important. Okay, bila you have a positive and negative number. Okay, so example here. The sign magnitude representative of decimal number for negative 31 and the positive 2 basically in unit is a byte. Okay, so apa you buat adalah you ambil negative 31 and again also the positive 31. So apa yang you buat, you convert the 31 ni kepada binary. Okay, so you tukar dia kepada binary. Okay. Okay, so you ada 1, 2, 4, 8, 3 campur 1, 2, 4, 8 12 lah campur 16. Okay, so 3, 1, 2, 3, 4, 5, 6, 7, 8. Okay. Okay. So here, you kena in a byte sebab dia kata is a byte. Okay, so you is a byte mesti dalam 8 bit. So maka bila dikatakan negatif 3 kat sini, maka the leftmost bit here, okay, the leftmost bit yang ke-8 bukan kosong. Tetapi dia jadi negatif 1. Okay, dia jadi negatif 1. Okay, because this one represent by 31, magnitude of 31, and then 1 is a negative represent by the sign. So that's why dia jadi negatif 31. Okay, sama juga dengan 31. Okay, 31 dekat dalam positive 31. So positive 1 you have 1, 1, 1, 1, 1. Okay, and then you have 8 bit. So the 8 bit byte, 1 byte is 8 bit kan. So the bit ke-8 dia adalah positive. So dia akan jadi kosong. Yang kosong ni sebab kena cukupkan 8 bit lah. So the leftmost bit kena letak kosong. Sebab dia sign dia adalah positive. So ini adalah 31. This is a positive of 31. Okay. Alright. So this is this example of decimal equivalent of segmented binary sequence of 100010. 1011111001. So the addition of number in the sign and method use a user convention of binary. Both have the same sign. The magnitude are being added and the same sign copied. If the sign is different, then the number has smaller magnitude is subtracted from the larger one. Okay, apa maksud dia? Kalau you tambah dua number dalam satu sign numbers, okay, use pakai convention of binary arithmetic lah, macam biasa kita tambah tadi. Tetapi apabila dia mempunyai same sign, maksudnya dia positif, maka you boleh add the magnitude macam biasa. Tetapi apabila you punya sign adalah different, contohnya satu positif, satu negatif, maka you kena tolak nilai yang the smaller magnitude must be subtracted from the larger one. Yang besar tolak yang kecil. So katakanlah yang nilai tu adalah yang besar tu adalah negatif. Maka dia akan jadi negatif. Okey. Okay, so this is the first complements of the conversions. Okay, itu sign and method. Oh, sorry. Kita ada example. Okay, the decimal values of the sum of the binary numbers. Okay, we have 1 0 1 1 0 0 1 1. Okay, this is the AB 2 4 6 8. Okay, confirm. And then you N tambahkan dengan 0 0 0 1 0 1 0 in the binary. Okay. So this is two numbers which is in the sign numbers. So macam mana you tambah dekat dalam bentuk sign magnitude. So sekarang ni apa you perlu buat? You tahu number ni is already in the sign numbers. So basically ini dalam 8 bit. So dia dah tahu dah ini dengan ini adalah sign numbers. So this must be negative and this is must be positive. So this one is the magnitude. Okay, so of course the same is the sign is not the same, right? So sekarang ni apa you buat? You convert this binary and convert this one to the convert this binary and convert this binary into a decimal. So contoh sini 1 2 4 8 16 32. So 32 campur 16 48. So 48 campur 2 50 51. Dia adalah negatif 51 base 2. Okay, plus. Okay, this is a positive values. So, bukan in the base tu dah. Okay, ni dalam decimal kita talk about in decimal form. Nanti saya padam. Takut dia keliru pula. Okay, so positive, so you have 1, 2, 4, 8, 16. So 16 plus 4 is 20. 20 plus 2 is 22. So it is with positive 22. So here, basically, you tengok kat sini, macam saya cakap tadi lah. If you have different sign, okay, so you boleh tambah terus magnitude dia. Tapi apabila you ada different sign, okay, kita tengok which one is the nilai yang paling bigger. Kita jangan tengok sign dulu. Kita tengok dia bigger. So, 51 is bigger than 22. So, you kena tolak lah. So, jawapan dia akan jadi negatif. Okay, 51 tolak 22 adalah, tolak lah macam biasa. Tolak 22 lah. So, it should be 9. 9. 29. Dalam decimal. So awak boleh tukar balik this 29 kepada binary. Okay. So kalau jawapan dia tak minta convert binary ke apa, ini pun betul. Ini dalam decimal. Ataupun you convert into this one kepada binary. So dia ni pun negatif mesti 8 bit lah. So 1. Okay. 29 ni. That's why guna conversion tu kena powerful dah. Okay. Baru you boleh dapat. Boleh bawa tukar kepada binary. Okay, 29 ni awak convert into a binary. Dalam kes ni dia tak pelanya, dia tak bagi tahu. Tapi kalau nak nampak dia dalam binary, awak kena tukarlah kepada binary. Okay, so jawapan dia. Okay, negative 29. So negative 29, so the leftmost bit should be negative, should be sign 1. So 29 ni, the magnitude ni awak tukar kepada binary. So awak kena tukarlah. So 1, 2, 4, 8, 16. Okay, so 1, 1, dah 24. 24 campur 4, 28 campur 1, 29. Okay, so yeah, the rest will be 1, 2, 3, 4, 5, 6, 7 dan 8. So 1, 2, 3, 4, 5, 6, 7, 8. So leftmost bit ni adalah the negative one lah. And this is your 29. Okay. Inilah jawapan dia kalau dia dalam binary. Dan ini jawapan dia dalam decimal. So this is how you do in the sign magnitude. Okay.